Hello viewers, last month I've been on analog devices seminars in Brno, and what I get is this development kit. It's called ADuCino360. It's Cortex M3 board, and we'll take a closer look at this device. And I was thinking I can shoot how I turn on this device and try to run a simple blinky program on it. So let's take a closer look on this kit. So this is how it looks like. You can see it's some kind of Arduino compatible footprint. Okay, so what we have on the board, I think it will be better seen on display. So it seems like it's made by some Polish company. And on the board you have a usual USB for power and bootloading, FTDI, USB to serial converter, some jumpers which are connected to TX-RX communication pins on the processor, and then you have some temperature sensors here, G sensor over there, and also a SVD debugger can be connected here. But what I would like to do today is upload the firmware over this bootloader and try to blink an LED. On the website and also in the package there wasn't any information supplied, so I went to this Polish website which I found, and there's everything in Polish, so I'm thinking that I try to find the datasheet and some instructions on official Analog Devices site. So the easiest way to get some support for this board is to Google the name of the CPU, not the board but the CPU. So that's ADuCino360, and on their site I'm going to search for some utility so I can flash this chip over USB. So okay, here it is. Serial download via UART. So after downloading this utility, I can try to talk to this device. It's interesting. So it would be nice to connect the board. And it's COM46, okay. And what I have to do now, I can try to erase this board. So I press start, nothing happens. And it says press download and pulse reset on hardware, so here is reset. That does nothing, and maybe I have to press both buttons. Okay. Oh, perfect. So it's erased. And I can try to program some application. This is the default sample application, which is in the same directory. So let's try that. Okay, so it's uploaded. So also I have noticed that there is no LED on this board, just a power LED, and there's no usual LED on pin number 13 like on Arduino boards. So I have no idea what this sample application does, and I can connect it to the oscilloscope and we'll see. So usually the LED is on the last pin. Oh, it's... Ah, here is something changing. Perfect. So I just uploaded a simple LED blinking sketch binary to the board. Okay, I try now to erase the board. Erase. Sorry. And then I need to press again the two buttons. And it's erased, yeah, and the output stays in high. Alright, what now? I would like to create the same sample application so I can rule this processor. So let's start to find which IDE I will use. I have a few IDEs like Cocox, Atodic Studio, Bare Metal Eclipse, and different Eclipse versions, and EMBlocks. Also, it's called bit blocks right now, I think. So let's find what's the best IDE to start with this board. I want to go open source, of course. So no Microvision or Kale. So alright, so it seems this EM IDE, it's free IDE, okay, and it supports this board, I guess. It's blinky, so it seems that I can use this to build my simplest application. So let's download and install this this IDE. So IDE is up and running. I can create a new project. There are templates, and here is our analog blinky. So the new code is generated. Let's take a look what is happening here. Okay, so some watchdog thingy, clocking, and here is what I'm interested in. Okay, so this code should blink on pin 1.3, which is exactly the same pin like in our previous example, which I downloaded directly to the board. And then there is some toggling where with some semi-millisecond delay function. Okay, so let's try build this. Blah blah blah. Yes. And it all went well, and we have some binary. So output, debug, and we have L file. We will need a hex file, so I already take a look how to enable hex file generation. So debug, generate. Okay, let's repeat it. And perfect, we have hex file. So I can try to upload this hex file, and I can take a look if we get some waveform. Program, I'll go with AutoFlash. So now I won't have to use this utility anymore. I just press the button on the board. So need to move it. Okay, so reset. So I flashed this. So I flashed the board and there's nothing on the output. Okay, so we have some difficulties here, and that's also why I making this video, so we can learn something and troubleshoot this development board. Okay, so the first thing I would like to check is the memory and initiation script. So the linker script first, and I need to find a datasheet for this processor. It's interesting, analog peripherals are noted first, and the microcontroller is starting in the middle of the nodes. So how many memory do we have? I guess I will have to find a reference manual, not this. User guide, using, oh, this seems like what I'm looking for. Hardware user guide, perfect, we have a lot of information here. So I will be interested in flash, clocking, deck, flash controller. Okay, so we have 128 kilobytes of flash and 2 kilobytes of RAM. Where am I? Here. Okay, 8K of RAM, 128 of flash, and also I'm interested. Okay, the flash starts from address 0. Where is the RAM starting? Oh, here it is. So code from 0, and then SRAM with this address. So it's exactly the same address we have set. We have here. Okay, so I guess the code is aligned right, but now I have to find out what's wrong with this binary, this hexadecimal file. Also, this board has, as I said, support for debugger, but I would like to get it running over the USB right now, and I would play with debugger later, maybe. This hex doesn't work. So I would like to take a look what the compiler does and what's the listing. So I need to generate some listing from L file and binary file from this L5 also. Alright, so I've prepared a small batch file which will just object copy our L file to hexadecimal, then to binary, and also it will dump listings of our assembly. So let's run that, and if everything runs well, and we have some outputs here. So where do I start? Well, let's take a look at the assembly listings right now. So what do we expect? We expect some code which is starting. We need to find where the reset vector is. Okay, here's a reset handler, and it's on address 200 hexa. So what happens first? It sets some stack pointer. I have no idea why this is here, because this processor has not FPU. It's no. Then it initiates the libc library, and after that it finally jumps to main function. So I've made some tutorial last month, and there's some STM bare metal blinky program, so you can take a look how the processor knows after the power up where to find your program and what happens. What is actually need to know is that the first 4 bytes are the stack pointer value, and the next 4 bytes are actual reset vector address. So when I take a look on the listings and I search for reset vector again, reset handler, so it starts at 200. And when I take a look on generated binary file, then I see this is the reset, this is the stack pointer, and this is the reset vector. And as you can see, it's 200. Yes, you read from right to the left because of the NDNS of this processor. So it's 200, and that's exactly what I expect to be, because 200 is a reset handler. So it seems like the processor knows where to start the application, but it has some issues with blinking. So maybe I can take a look further to the code. And maybe what is suspicious is this FPU settings. Maybe it's jumping to some exception handler. So I have no idea actually what happens if you call this registers and addresses when there is no FPU on the unit. So I can try to jump to main just before this FPU settings. BL actually means jump with linking. It's a branch link, so it's actually calling a function with keeping the return address on the stack, but that's okay because our stack is set over here. The jumping through the function should work. So I recompile the code. I take a look. Yes, the time is old, but it actually changed the size, so I can refresh the chip. And nothing happens. The output is still in logical 1. So we have to dig deeper. Okay, well, what I will do, I will put this jump to main right after the setting the stack pointer address. So rebuild, reset, nothing. Again, just straight line, no blinking here. Alright, so I give this back, I keep it like here. Actually, this doesn't seem right. I don't know why there is 0, because we are blinking on port 1, so I can try to repair this. So the total line is okay, but these 2 lines were wrong, so I can try to rebuild it again and reflash. And again, nothing on the scope. So what I've noticed is that the reset vector has also another vectors which aren't used now. So here are some here is some dummy address where is some infinite loop. So, and what catched my eye is that the ARM Cortex-M3 processor is thumb instruction set only. So the old ARMs could interwork. It can work with ARM instructions or thumb instructions. But Cortex-M3 is special that it only runs with thumb code. Thumb code is some superset of ARM instructions, and each instruction is 16 bits long, not 32. So the processor will know whether it's jumping to ARM instruction set or thumb instruction set based on the least significant digit. So if this address is even, which is this address, yeah, 0 is even, it knows that it's jumping to ARM 32-bit code, and when there is odd address, it knows that this function is thumb code only. And because the Cortex-M3 is thumb code only, I'm very suspicious that this address is not right, that there should be 0, 1. Okay, so I'll try to take a look on the default example blinking application which is working, and I can compare this. Alright, so I need to somehow convert this example application, blinking application, which came with this flashing software, and I need to create binary from this hex file. Well, after some googling, I found a hex-to-bin converter, and I created a bin file from this hex file. So when I open this bin file, I can see that the blinky application, which came with this flashing software, has flashing vector on address 2400. And this is the interesting part. This is an odd number. So here we have 9 here. As you can see, in the next reset, the next function vector is also even, and the rest is the same. So my compiler is doing something wrong, and because of that, it's not setting the least significant bit to this reset vector. So I have to figure out how I change this address to this address, right? I can also try to hard code it. I'm not sure about the hex format. To 1, save, okay. Let's try to reflash it. Nothing happened on the scope. Maybe I'm right, but somehow I need to force the compiler to put here this bit automatically, not to edit it directly in the binary output. So what I would like to check is whether the compiler has the right thumb parameters in the build options. So produce debugging symbols, and this is the thumb, so this could be okay. Right, Cortex-M3. So let's try a little bit googling. Okay, so I found some forum, and here's some hint that someone is having a similar program, and there's a directive in assembler which can force the compiler to call it like the thumb instruction set. So let's put it here on the reset handler. Surely, yes, I have to put it. There's also another side. So a preset function. Yeah, my label like that. Compile. And upload. Oh, we are blinking. So it had to do something with that least significant bit. So I try to generate the binary file. No, not. And yes, it's making right address, 201. So I'm blinking, and now just for fun I try to blink the fastest I can without this ugly delay. I can also unroll this loop a little bit. Sorry. Compile, refresh. Oh, okay. So I have to stop this. And I'm toggling at frequency 1.7 megahertz. There's a slight jitter because of the while loop. So when the program counter gets to the bottom of my loop, there's a jump instruction to the top, and that's why there are some glitches over there. Okay, so 1.8 megahertz frequency is what I can get now from the chip. So I'm quite happy that I run some custom application on the processor, and I'll try to take a look on this board later, and I will see what I can use this board for. And this video wouldn't be complete without the actual blinking, so here we have it. So once again, thanks for watching. Like or dislike this video, comment, do what you like. See you next time.